Hi, and welcome to another R Labs tutorial where we will talk about loops. There are different types of loops in R. In this video, we will be focusing on for loops, and in the next video, we will talk about while loops. There are also repeat loops in R, but for loops and while loops are the common ones that we will see in our video tutorials. So in general, with for loops, we have the word for, followed by a set of round brackets where we specify an index variable. I is commonly used, but it can really be anything that you want it to be. We'll see in one of our examples that we use the word temp as an index variable. And then we write the word in, and we specify a vector. Next, we have a set of curly brackets inside which we put multiple lines of code or commands. These commands will be repeated once for each element of the specified vector as the variable successively takes on the values of that vector. So let's start with an example of this general form. So here in RStudio, we can write for I, there's our variable, in 1 to 5, and that's our vector, print I squared, that's our command. And we get this nice list of numbers printed out. So let's just visualize this a little bit here. So here's what we typed into R. The index variable is I. The vector includes the numbers 1 to 5, and then we want I squared as the output. For the first iteration of the loop, or the first time the command print I squared was executed, the index variable I was assigned the value for the first element of the vector, so 1. So in this case, since the command asks to print I squared, we would get 1 squared as the output, which is 1. In the second iteration of the loop, I would be set to equal the second element of the vector, so in this case 2. And then the output I squared would be 2 squared, which is 4. And this continues until the command has been executed for all 5 elements of the vector. And so we can compare our answers to those that we got from the R console, and we can see that they are exactly the same. Now there are several variations of this general for loop. First of all, the vector specified in the loop does not need to be sequential. So instead of using the sequence 1 to 5, we can use the concatenate function to specify the vector -3, 6, 2, 5, and 9. And we can print I squared and close our curly brackets, and we can see that it obviously still works. Also, instead of writing our vector inside the loop, we can define it beforehand, like this. So x gets concatenate, -3, 6, 2, 5, and 9, and we can call up our vector x. And then we can write our for loop specifying x as the vector. So for I and x, print I squared. We can also print more than one thing. So for example, instead of just printing I squared like we have been doing, we can print both I and I squared. So here's our vector x, and we can say for I and x, print concatenate I and I squared, or print a vector containing I and I squared. And there we go. So here are the I values, and here are the I squared values. You might have noticed that the output that we get from running a loop is not usable. We can't really do anything with it. We can look at it, we can recopy the numbers, but we can't, for example, take the mean of the output or add these numbers to an existing data frame. But that's okay. We can fix this small problem pretty easily. So we'll go back to our first example of printing the squares of the numbers 1 to 5. The first thing we'll want to do is create an empty vector to store the 5 elements of our output. And now we start writing out our loop like normal. We say for I in 1 to 5, open curly brackets, and this line of code states that the ith element of our empty storage vector is going to be filled by I squared. So for example, in the first iteration of the loop, I is equal to 1. So the first element of the storage vector is going to be 1 squared. And then we end off our code with a closing curly bracket, and we can view our vector. And you can see that we have certainly squared the numbers 1 to 5 and stored them in this vector. And that's really handy because now we can use these numbers. So for example, we can take the mean of them. But what happens if we don't have a nice sequence starting at 1? What happens if we want to store the squares of our non-sequential vector x? Well, we can certainly make another storage vector called storage2, and we can execute the same command as before, But we get a vector that has more than 5 elements and that has a 0 and some NA values, so our code really didn't work. And that's not surprising because with the different elements of x as our index values, we can see that we have a negative index, which complicates things in itself, and we also don't have 1, 3, or 4 as indices, so we are not correctly specifying what we want the first, third, or fourth elements of the storage2 vector to be. And then with vector indices of 6 and 9, we are referring to the 6th and 9th elements of the storage2 vector when we only want 5 elements in the vector. But what we can do is use the elements of a sequential vector instead of the elements of x as index values. So here's our vector x, and we can make yet another storage vector, storage3. It's empty right now, and we're going to say for I in 1 to 5, the ith element of our storage3 vector is equal to the ith element of our x vector squared. So for example, when I is equal to 1, the square of the first element of the vector x is going to be stored as the first element of our storage3 vector. And there we go. Now we probably won't ever want to just square a number, but here's a more applied example. We can convert degree Celsius to degree Fahrenheit. So we have a vector containing temperatures in degrees Celsius, and we specify that the corresponding temperature in degree Fahrenheit is degree Celsius times 9 divided by 5 plus 32. And we can print the vectors containing all of the temperatures in degrees Celsius and the temperatures in degrees Fahrenheit. In a previous video on conditional statements, we talked about how if statements on their own and combined if and else statements do not work on vectorized arguments. So for example, we can have a vector of temperatures, and we can write a typical if and else statement. So if temp is greater than 0, print warm, else print not so warm, and we get our warning message. Now we already looked in our conditional statements video at one way to solve this problem, and that was the if-else statement. But another way to deal with this is to add the if and else statements to a for loop. So for temp in this vector, or for each of these temperatures, if temp is greater than 0, print warm, else print not so warm. And we close both of our curly brackets. And just like the if-else statement, this seems to have done the trick. Great, so now we hopefully have a handle on general for loops, and we can move on to something slightly more complex. The nested for loop. Nested for loops take this general form. So we have our first loop for variable 1 in vector 1, and just a reminder that this number sign allows me to put in annotations. So I'm just reminding myself that this set of curly brackets belongs to the first loop. Next, inside this first loop, we add another loop. So for variable 2 in vector 2, and we have our second set of curly brackets. And we can keep doing this as many times as we please. So I'm going to end with for variable n in vector n representing any number. And then finally you enter your commands. Now notice that each new level of this code has a different indentation. In your RStudio script, this is just a nice way to break up and keep track of big chunks of code. So don't get too overwhelmed by this mess. We'll do an example and everything will look a lot nicer. So we have for I, our first variable, in 1 to 3, our first vector, and we nest another loop within. So for j, our second variable, in 1 to 2, our second vector, print I plus j. And then we close our curly brackets, and we get this list of numbers. So where did they come from? Well, basically our code here is saying that we have 3 I values to loop through and 2 j values to loop through, and we have to find every combination of I plus j. For our first iteration of this first loop, I will be equal to 1. And then while I is equal to 1, j can equal 1, so I plus j would be equal to 2. And then j can also equal 2, so I plus j would be 3. And then for our next iteration of our first loop, I would be equal to 2. And then in the same way, while I is equal to 2, j can be equal to 1, in which case I plus j is 3, or j can equal 2, in which case I plus j is 4. And we do this for our third value of I, and in the end we have our output, 2, 3, 3, 4, 4, 5, which is exactly the same output that we saw in RStudio. At this point, you might have noticed that loops are not the only means to a particular end. So looking back at our very first example in this video where we simply raised each element of the vector to the power 2, we could have easily skipped the whole loop entirely. We could have simply defined our variable x as 1 to 5. And then we could have created another vector, I have called it loopless, by squaring the elements of the vector x. And so without using a loop, we have achieved the same end result. In R, it is usually better to avoid loops as much as possible. It's not so much a problem with these small bits of code that we've been practicing with, but when working with large data sets, R runs vectorized operations much more quickly and efficiently than loops. But loops are often more transparent, meaning that various programs use loops, whereas vectorized equivalents are often program specific. And loops are sometimes inevitable as well, so it is good to learn them. Thanks for listening to this RLabs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.